Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to the last lecture of the 4th week of this ongoing course on understanding and reducing greenhouse gas emissions, where we are focusing on scope 1 and 2 emission reduction through building design and construction. This is the lecture about understanding the role of buildings and related emission. In the previous lecture, we have looked at the calculation tools, the category of GHG protocol and the tools associated with them. And we also looked at some of the examples using these calculations. Now, in this particular lecture, we are primarily going to focus upon the life cycle of the building, the emissions that accrue from the entire process of construction, use and demolition of a building as a product. So, we are looking at the whole building life cycle and who all are the stakeholders who are associated with different stages of this building life cycle. And then we are going to quickly look at the status of emission from construction and where are the possibilities for interventions for reaching a net zero emission status in case we are talking about buildings. What are the different scopes, which activities fall in which scope depending upon the activity, the project of each stakeholder or the related company. So, this is what we are going to look at in this lecture as we are gradually focusing on the emissions through buildings. So, starting with the stages of whole building life cycle, very simple, we clearly understand that the whole process of constructing a building starts from extracting the materials. So, producing the materials which are going to be used in the building. So, if we say brick, the raw material extraction for brick, which is say soil, clay, that is where the whole cycle, whole process starts. If we say glass, so the extraction of sand is where the whole process will start. Now, all the materials that are going to be used in the building, which may be of course used in a manufactured form, in a processed form, the extraction of raw material is the starting point. So, we are starting the life cycle of the building from raw material supply, from extraction of these raw materials and then transporting them to the site of manufacturing where the material will be processed, it will be manufactured. So, manufacturing it and then further transporting it to the site of use where the building is going to be constructed. So, this is the part of this production cycle where we are extracting the raw material, processing it, manufacturing the material to be used in the building, transporting it to the site. This is the production part. After that, when the material has reached the site, we are constructing the building. So, we are talking about construction, all the installations that are going to happen of different equipments, different services, and in between we also have transportation, which usually is significant factor for which is contributing towards emissions. Some of the activities are also happening in between. For example, between production and construction, almost simultaneous to that is the process of design, the research and design. So, different stakeholders, architects, engineers, they are coming on board to design the building, what the building is going to be. So, from production to construction, while we are transitioning, we already have design. But when we are talking about the emissions and when we are looking at it, we will see that there is much lesser contribution of this team directly, but the influence of the activities, influence of the policies and design, this design team, this engineering and architecture team is having is significant. So, In the whole process of building life cycle, while this is an additional part, it has a significant role to play in the overall emissions from the building as a product. Once it has been constructed, it is handed over to the user to operate. So, we have operations. Largely the scope 2 emissions coming from the building life cycle are coming through the operations, the use of the building. So, most of the electricity is going to be consumed during the operations, and which is going to give us the scope 2 emissions. So, in addition to that, in addition to the use of building, we have the regular maintenance, repair, replacement, refurbishment works, and that is all part of operations. So, it is not just building envelope, we are talking about all the equipments and services that are going within the building and are going to be used by different stakeholders, users. Once the building has completed its entire life, service life, after that it is the end of life phase where the building may be demolished, it will be demolished. The material which can be reused, or it can be put into processing, it can be recycled. So, that process will happen. So, we will have deconstruction or demolition, we will have waste processing in case some waste can be reused or recycled, and then we will have disposal of the remaining waste which cannot be recycled, and for that we will have transportation. For all of this we will have transportation. So, this is the end of life stage. In case we have the recycling potential, the material which we have identified here and transported will be sent for recycling, reuse or energy recovery. So, there may be some post processing which might be used, or we might be upcycling into some other form. So, this is beyond the building life, which is even after the building has completed its complete cycle of life, and it is further going into the use in case it is processed, and that is what we are seeing as the different stages of whole building life. Now, what we are also going to see from all these activities that are with us, we have to identify building as a product, and during the manufacture and use of this product, again we will have the upstream and downstream activities, and we will have the operational phase where the building will be in use. So, if you look at this entire cycle here, the same stages when we bring here. So, we have the use stage, we have the pre-use or what we know as the upstream activities, and we have the post-use which we know as the downstream activities. So, the use stage, which is when the building is in operational use. So, these are the activities that are going to be there, which we have just seen: the use of the building, there will be maintenance, repair, replacement, refurbishment. There will be emissions coming from the operational energy use, which will be the most significant part of the emission, overall emissions from the building as a product, and operational water use. So, while we are talking about emissions alone, the emissions are also accruing from the electricity consumption or fuel consumption for distribution, supply and use of water, which is also a significant contributor. This is what we are looking at in the operational stage or the use stage of the building. Now, if we look at the upstream activities, so which are leading to the building use stage, we are talking about the product manufacturing stage and the construction stage, which we have just seen, and the activities within them. There are many more activities. If we go on to detail out these project activities, there are going to be multiple smaller activities, sub activities, but here we are broadly looking at these. So, there will be raw material supply, transportation to the manufacturing unit, then we have manufacturing, then we have transportation of the manufactured product and to the site, and then installation or construction process on the site itself. So, this is all upstream stage of the building. And if we are looking at the downstream, once the use has been completed, then we are talking about demolition, transportation of the demolished debris, which can be put into recycling unit or reuse, and then we have waste processing and further disposal. In case we are going ahead with recovery or reuse, that is out of the scope of emissions, but most of these emissions that we are going to count are within this bracket and all these activities. Now, as I said that each of these activities can be detailed out. For example, we are looking at only raw material supply. Now, depending upon the choice of material, the raw material supply and the emissions coming from them will change. Consider this, if as an architect I recommend, I specify AAC blocks to be used in this building vis-a-vis CSEB, compressed stabilized earth blocks to be used in this building. Now, the emissions that are going to come from the extraction of materials and also the manufacturing of these two products is going to be significantly different. While it is not going to be the scope 1 for me as a user, I might be an academic, I might be a university where we are using the buildings, and the building as a product is something that has been delivered to me, but the scope 3 upstream emissions include the emissions that are coming from the materials that have been used in this building. So, if I am using CSEB versus AAC, there will be a huge difference in the emissions. That is what we are talking about. However, we have to make a judicious choice. We have a lot of different constraints. GHG emissions are not the only constraints due to which, or the requirement due to which certain decisions are taken. For example, which we all know that the materials are dependent, the choice of material is dependent upon how high the building is going to be. For multi-storied buildings, we can't be using very heavy materials, we cannot be making very thick walls, while if we have buildings which are horizontally spread and only on ground floor, where land is not as difficult to obtain, where we have availability of land, there heavier materials can be used which have lower GHG. But the moment we are looking at vertical buildings, there the lighter materials, most likely we are going for synthetic materials or metals, they will always have higher embodied energy. A lot of energy is consumed during the manufacturing, which implies that a lot of emissions must be taking place. So, the decision, however, in the same condition, the given context, the challenges that we have, we can always make a choice between materials where the GHG emissions are low. This entire emission set from scope 1, 2, 3, both upstream and downstream, is going to affect any business, not just the building sector or the construction industry. It is going to impact every sector whichever is using buildings, and there is hardly any business which does not require buildings to operate. So, with this idea, we will move forward and understand how buildings are responsible for emissions to different businesses, to different sectors, which is what we are going to see in the coming week, the week 5. Now, if we look at all these stages which we have just seen, the pre-use, use and post-use, we have different stakeholders who are coming in at different times. So, we will have the earth or eco-science professionals, we have the companies who are involved in extraction, we also have agriculture and forestry industries who might be associated for supply of materials, for example, wood or bamboo or similar such organic materials, they may be procured from these stakeholders. Then we have architecture firms or engineering firms who are going to be involved in designing and selection of materials, selection of equipment, all the services that are going to go in the building, but only the design of them. Once it has been designed, then we are moving to construction firms or contractors or developers. Now, they are responsible for actually manufacturing the building as a product, constructing it. So, a lot of scope 1 emission from this entire stage of building life cycle are happening here, stage 1, scope 1 emissions, if we are looking at building as a product, not looking at individual company. We will come to that, because the scope 1, 2 and 3 will vary depending upon the goal of the company or the activity goals of the companies, which is what we have understood so far. Then we have building occupants and the communities as users of these buildings. we have waste management services, and we also have the secondary production specialists, where we are looking at the recycling, upcycling and the reuse of these materials. So, these are different stakeholders in this building life cycle whom we are looking at. Now, each of these stakeholders, they have different aims, they have different key concerns, and if we understand that, we will clearly be able to understand the scope 1 and 2 and 3, how the emission for each company, each stakeholder will be delineated. So, for example, the investor has the concern only on return of investment, while the banks or financial institutions, they also have a concern on return of investment. But the manufacturer or supplier, his main concern is energy supply and availability of natural resources. These are the resources that he needs to continue to work, continue to supply the material. Contractors require this continuous supply of materials and energy and also workforce. For designers and planners, they need to have the knowledge base updated every now and then, they have to be creative, and there has to be an efficient application of the knowledge and technologies that they have understood, they have read about. The user, for user it is about well-being, it is about also economic feasibility and also optimization of the economics along with health and well-being and overall lifestyle. Then we also have stakeholders who are not directly connected with the building life cycle, but they are remotely connected or not or indirectly connected. For example, there could be public authorities who are involved in regulations and control of these buildings, NGO and civil society who are talking about social equity and access to information, research and education. So, not directly the architects and engineers, but for example, academicians who are creating this body of knowledge which is to be applied by the engineers and architects. So, their main concern is technology and knowledge, and we also have media where their main concern is democratic sharing of information. Now, with this understanding of the stages of building life cycle and also the key stakeholders, if we look at where the scope 1, 2 or 3 emissions are going to be through the entire life cycle of the building, approximately this is what we will get. Now, before I explain this, you have to be very clear that the scope 1 and 2 or 3 also will slightly vary depending upon the detail of activities and the ownership that we are going to consider, that is going to be there for individual company. Now, starting with the extraction company. The extraction company is involved in the supply, extraction and supply of raw materials. For them, the emissions that are coming, direct emissions that are coming from supply, extraction and supply of raw material is going to be counted as scope 1. So, the green is scope 1. This is scope 1 for them, and the entire activity which is actually the downstream activity, all the emissions that are accrued from that is going to be counted as scope 3. Now, here there is very little mention of scope 2 that you would find, because we are only looking at the stages of building life cycle. So, we are not looking at the detailed activities. Now, when this extraction company is doing this raw material supply for his own office, for running the machinery, for a lot of different activities, for carrying out this extraction process, he might be using fuel like electricity. Now, consumption of electricity as a fuel will go in scope 2, but since we are not detailing out all those activities, we are only looking at the direct emissions here, and scope 2 will be there for each of these reporting companies. So, for the extraction company, the emissions coming from raw material supply are going to be counted in scope 1, and rest of the emissions are going to be in scope 3 downstream. Now, if we are looking at the manufacturer, for manufacturer all the direct emissions that are going to come from manufacturing are only the scope 1 emissions. The ones from raw material extraction and supply and also transportation to the manufacturer, if it is to be done by a third party or the extraction company, that is going to count as scope 3 upstream, and the rest of it is going to count as scope 3 downstream. Now, there could be, here we have considered that there is a transportation company, a third party transportation company who is going to transport the extracted material to the manufacturing unit and the processed material from manufacturing unit to the construction site. So, for him all the emissions that are coming from transportation as scope 1 emissions and the rest of the emissions as scope 3. So, they will be upstream or downstream depending upon which transportation, which activity we are talking about, or if it is both, then only the transportation is going to be in scope 1 and rest is going as scope 3 within these. Now, if we look at architectural and engineering firms, none of these activities is going to be counted as scope 1 or even scope 2 for the architectural firms or engineering firms. For them, it is all scope 3 because they are delivering design as a product. The knowledge and the service is the product. So, for them the building, all these stages of building construction and use are going to bring them scope 3 emissions only. It is not going to be any scope 1 or 2 through the building process. However, the design has a significant impact. The construction, the selection of materials, the selection of construction technology has a significant impact on all these stages, the emissions. So, while it is all scope 3, it is no direct, but depending upon the design that has been made, depending upon the materials that have been specified, the scope 3 emissions would change. All of these emissions would change depending upon the decision that is being taken by the architectural or engineering firms. Then we have contractor or developer who is going to construct the building. For him, the direct emissions that are coming during the installation or construction of the building, that is going to be counted as scope 1 and the rest is going as scope 3 here for these activities. Also, if the responsibility of demolition or deconstruction of the building is with the contractor or developer, it will be one of the contractors, then the direct emissions resulting from this activity, deconstruction or demolition, is going to be coming here for contractor or developer, and rest is again going in scope 3. Now, if we look at user or owner or the community who is directly going to use the building, for them there is largely the emissions coming from the operational energy use. So, the operational energy use and operational water use, which is actually going to go in scope 2, is directly coming to the users and community. For rest of them, it is going to become scope 3. For them, the direct emissions, if we directly own the building, in case it is a leased building, then the emissions which are going to accrue from all these activities are going to become scope 3 if it is a leased activity. Now, that is also depending upon the lease. If it is, again as we saw, if there is a greater equity of there, or if there is 100% control over the building, then even these emissions are going to be counted directly to the, they are going to be accrued to the user's account, else it will be with the owner's account. So, owner, user or community is going to be having all these emissions coming from this entire basket of use as either scope 1 or sometimes as scope 2. If the, for why we are counting it as scope 2 here, maintenance, because if there is a facility manager or a service manager who is going to manage the entire building, then the emissions coming from maintenance, repair, replacement, refurbishment could actually be accruing to the facility manager or service manager here, the direct emissions, and the operational energy use and operational water use, which are going to take place due to the maintenance, repair, replacement and refurbishment, could be counted as scope 2 for the facility manager. The rest of it is scope 3. Now, this was the waste processing disposal. For some companies it may be out of scope, for others it may be well within the scope. It totally depends upon the boundary setting and the goal setting that we have already seen. So, depending upon what is the goal and boundary for an individual company, they will be counted as scope 3 or may be excluded even from the scope 3. But one thing that you have to understand here for any life cycle, any product life cycle, is that all the activities that are there as part of the product life cycle and all the stakeholders who are going to become part of this entire life cycle of the product, each activity is going to become scope 1 for somebody or the other. They may have their scope 2 quite consistently, but they will always have one of these activities will be scope 1 for somebody. So, if we look at all these activities, we are looking at this scenario where each of these activities is becoming scope 1 for some or the other stakeholder, except the operational energy use or the electricity consumed in the facility during the entire life cycle. That is going to become scope 2 for one of the stakeholders. For any product, we are going to look at the entire life cycle stages and all the stakeholders, and then there will be absolute clarity as to where all the emissions are coming from and who all are going to be responsible for it directly or indirectly. Wherever we have scope 1 emissions, it implies that that stakeholder is directly responsible for reducing the emissions. It is the direct activity that is happening with that stakeholder, and rest of the stakeholders, while it is still in the value chain, but they have less control over it. Sometimes they may have greater control, so then it may become 1 or 2, but all other cases it will largely be in the value chain and scope 3. So, I hope this makes the understanding of building as a product very clear to us. Now, looking at why it is so important to reduce the emissions from construction sector, let us look at quickly some of the numbers that are coming in. So, a lot of this data is actually collected and published by the UNEP hosted Global Alliance for Buildings and Construction, and we commonly know it as Global ABC. So, they usually continue to monitor the progress of the buildings and construction sector on a global scale. They look at different specific regions, they look at the materials, they look at the technologies, how the buildings and construction sector is transforming, and they report it annually. So, there is an annual reporting of the observations on building and construction. So, if we look at the changes, now most of the data is coming from this report and it comes out annually. So, if we are looking at the key changes in building sector between 2015 and 2020, with a clear understanding that 2020 was a pandemic year. So, there was a significant reduction in the activity, in the construction activity. With this idea in mind, let us look at the figures. So, overall if we look at from 2015 to 2020, we see that the emission intensity per square meter is coming down across the world. Now, these are average numbers. So, which means that the construction is becoming emission efficient. So, while the building area is increasing, we are seeing a reduce in per square meter carbon dioxide emissions or GHG emissions, and simultaneously, which is obvious that the energy intensity must also be coming down, because a lot of emissions that are happening in the buildings are due to consumption of energy. So, energy intensity per square meter is also coming down. But if we look at the other number, which is the gross floor area, so overall the floor area across the world of buildings is continuously increasing. So, if we look at this, the intensity per square meter of energy and emissions is reducing, but the total area is increasing. So, if you look at the absolute numbers, we would still find that the buildings and construction industry has a significant share in the overall emissions if we look at just the absolute number and do not compare the trend. So, absolute numbers would still be high and the slope might decrease, but they are constantly increasing because of increase in this floor area. So, if we are looking at the nationally determined commitments, so more and more nations are committing to reducing the emissions from buildings, which is a good indicator, which implies that more nations are coming together to reduce the energy intensity or the emission intensity of the buildings. So, which implies that more and more policies would be coming, which is what is the next indicator, number of countries with building energy codes. So, if this is increasing NDC, automatically we would see a surge in the building energy codes. So, mandated energy codes, more nations are coming up with building energy codes, and then we also see that the investment is increasing, which means that buildings and construction industry is here to grow even further. We are seeing a lot of investment going in the buildings here. They also have developed a global buildings climate tracker, where they are looking at how much of emissions and the impact on carbon dioxide emissions is coming from each of these activities. For example, we are talking about the building codes and regulations. So, how much impact of this is coming on carbon dioxide emission, or renewable share in global final energy demand in buildings. So, this is another activity which is significantly affecting the carbon dioxide, the GHG emissions coming from building and construction industry. Then we are also looking at green building certification. More and more green building certification implies that there is a greater awareness and selection of materials which are more sustainable, building designs and practices which are going more towards green, environment friendly and sustainable, thereby reducing the emissions. So, these are the action agendas and these are the impact agendas that we are talking about. So, they have identified 6 such indicators which are responsible for emissions. And then if we look at the total energy consumption and emissions which are related to overall, and if we look at the buildings, we see that a large share of this is actually coming from buildings and construction industry, which is approximately, which is coming very close to 50%. So, we have a significant amount of energy that is actually going in buildings and construction industry, and thereby a direct relation to the emissions that are coming from this building and construction industry. Now, this is a prime reason, or this is a significant reason for us to consider building and construction industry to reduce the emissions that are accruing from this entire industry, whether we are related with building or construction industry or not. Irrespective of that, we have to reduce. Now, if we look at one of these indicators, which was building codes, we will see that more and more nations have actually come up with building energy codes. So, all the dark blue and the light blue that we are seeing on the world map here are the nations or the states which have already notified, either mandated or not mandated, but they have notified the building energy codes in their respective nations or states. In some cases which are in green here, the building energy codes are in the process of development, and the others which are fewer are the ones where no known building energy code is existing. But we can see clearly that large part of the world, largely almost all the world is having, most of the nations are having their own building energy codes, and a lot of them are also having mandatory codes, which is why we see this indicator where the energy intensity per square meter of buildings and also the related emissions are coming down, but of course, the overall number is increasing. Now, within these emissions, if we see that the construction materials, they dominate the resource consumption, and also through the building life cycle energy, besides operational energy use, we will see that most of the emissions are actually coming from the manufacturing of the material, extraction to manufacturing of the material, building material that is going in the construction sector. So, besides the design of building to reduce operational energy use, we also have to focus on the selection of materials and also the manufacturing of it. If we look at the demand of steel and cement by regions, we will see that overall the demand is also increasing. 2020 you will see a slight dip, but then we know clearly that this was a pandemic year from 2015 to 2020. So, this dip is not really indicative that there is a dip in the cement and steel consumption. It is just referring to the pandemic year. But overall, if we see the consumption of steel and cement, the materials like steel and cement and also glass and other materials, it is significantly increasing across the world. There is no region in the world where this demand is coming down. But this is something that we also have to see when we are recommending, when we are suggesting materials based upon the technology. And this can also be considered as part of policy when we are talking about the city planning, how the city grows, how much land is available, whether we are going for vertical growth, horizontal growth, or how we are growing, that will also govern, it will define what materials can be used in the buildings. Now, if we look at the global buildings energy demand and the floor area growth, we can see, and this is a projected growth for 2050. So, what we are actually aiming at is that while the floor area continues to increase gradually, which is how it is doing, we are looking at, we are closing in on 2025, and this was a projection of course. So, we are seeing a slight, not a very steep slope, but it is a gradually increasing slope of floor area, but with the help of efficient materials and technology and also the use, the intent is to bring down the intensity, the energy demand of the buildings. This will be the most ideal scenario, and if we really want to achieve the net zero emissions by 2050. For that, we will have to bring down the energy consumption and emissions from the buildings significantly. This is a repeat, Saurabh, ise hata dete hain. Now, if we have to transition to, for this building and construction industry, to net zero emissions, then we have to act. There are certain aims that we have to set for each of these activities. As I said, the planning, urban planning, new buildings, existing buildings, they are all party to how the buildings will perform. What will be their energy consumption and emission intensity? It will be determined by urban planning, it will be determined by the materials that we choose. So, the manufacturing, the material development sector, it will also be dependent upon the appliances and systems that we are using. So, we need to focus on each one of these new buildings, existing buildings, building operations, how the buildings are going to be operated, what are the appliances and systems that are going to go into the buildings, the materials that we are going to use, how resilient, what are the strategies for resilience, because if the buildings are not resilient enough, we will need to raise them down very often. Their life cycle will be less. If they are resilient, their life cycle will be more, and the same stock of building can continue to remain in use for a much longer time if it is resilient. So, we have to design the buildings to be more and more resilient. And then if we can supply clean energy, we will be significantly bringing down the emissions, because most of the emissions through the building life cycle are actually coming from operational energy use in the scope 2. So, if we look at all these, and then how can we bring it closer to the net zero emission? We can do it by doing all this that we are mentioning here. For example, if we are talking about clean energy, we have to accelerate the decarbonization of energy and heat. So, we have to depend more and more on renewable sources of energy. We have to use more and more of sun, hydro, wind, all these sources have to be used, and we have to decarbonize the electricity and heat that goes into the buildings. If we look at resilience, we have to build in the resilience for buildings and communities. We have to develop integrated risk assessment and resilience strategies. The reason that more resilient buildings have a longer life. Then if we we look at materials, we have to promote the use of low carbon materials. We have to develop embodied carbon databases, which all these actions are actually in process, but there is a long way to go. For example, if you are looking at India, we still do not have a very comprehensive embodied carbon database. We have to raise awareness so that people are encouraged to use more low carbon materials. They are able, so first we have to manufacture, we have to develop such materials which are low carbon, embodied carbon, and then we have to also train and make people aware of the choices that are available to them. A high carbon choice versus a low carbon choice, and people have to become aware to select the low carbon. Similarly, we have to act on all of these. For example, if we are looking at urban planning, we have to prioritize integration in rapidly expanding cities. We are talking about transportation, we are talking about the densities, we are talking about the expansion, the horizontal as well as vertical expansion of the city, and each of this policy has a direct impact on almost all the rest and the entire life cycle of building. So, we have to, if we have to reach a net zero emission, we have to prioritize integration in rapidly expanding cities. We have to prioritize high efficiency standards. So, the newer energy codes, they have to mandate very high efficiency standards, and for existing building stock, we have to accelerate the action on building retrofits. So, the buildings have to be retrofitted to be more efficient. As the time is passing, we are seeing that, as we saw, that the energy intensity came down, but what about the existing buildings? So, we have to act on retrofitting these buildings. Then we have to facilitate maintenance and building management, because a lot of times the building is constructed to be an efficient building, but the operations do not, or operations are extremely inefficient, which may result in an inefficient building at the end of the day. Then we have to simulate demand for energy efficient appliances, and we have to encourage the market for efficient appliances. We have to increase the standard also of the appliances. So, if you are aware with the BEE star rating, so 10 years back we did not have a lot of companies which had their products as star rated, but now as we are moving forward, more and more companies are coming under the umbrella, they are adopting the scheme, and also we will see that 10 years back the star rating of a 5-star appliance is today probably just a 2-star rating, which means that the efficiency is increasing. A 5-star of 10 years back is today a 2-star, which means the 5-star of today is much more efficient than the 5-star of 10 years back. So, we have to encourage the use of energy efficient appliances that are going to be used in buildings, and also create a market and policy mechanism to promote and support them. Use of low carbon materials, build in resilience for buildings and communities, and acceleration of decarbonization of electricity and heat. This is how we should be able to reach a net zero emission in building and construction industry. Now, this is a huge task, this is a Herculean task that we are looking at, but it is possible. So, if we are able to put in place, if we are able to implement all these mitigation measures, then by 2050 we can aim towards a net zero emission building and construction sector and industry. If we have a net zero emission building and construction industry, it will be a significant reduction in the overall GHG emissions of the world. And also, if we are looking at individual sector reporting, they will also have a significant emission down in their accounting, in their account books, where they are accounting for GHG emissions, because all the emissions scope 1, 2 and 3 coming from buildings, which may be a scope 1 or scope 3 for most of the businesses, is going to significantly come down. I hope with this we have clearly understood the entire life cycle of the building, how and where the emissions are coming in this entire life cycle, and what are the different stages and stakeholders. If we have understood this, in the next week we are going to look at individual sectors, where are scope 1 and 2 and 3 for them, for example, universities or airports or IT sector. We will also see how the buildings are contributing to 1, 2 or 3 scope emissions for that particular industry. So, we would know where to act if we want to reduce each of these. So, thank you very much for being with me here today. See you in the next week with a new lecture and some examples of different sectors and their related emissions. Thank you. Bye-bye.